Hello everyone. In this video, we shall verify linearity property of DFT. Its statement says that in time domain, a times x1 of n plus b times x2 of n, where a and b are the constants and x1 and x2 of x1 of n and x2 of n are capital N point sequence. This is equal to, in frequency domain, it is a times x1 of k plus b times x2 of k, where again a and b are the same constants what we had in time domain, and x1 of k and x2 of k are the n point DFT of x1 of n and x2 of n. So we'll verify this mathematically first. Say x1 of n is 1, 2, 3, 4 and x2 of n is 1, 1, 2, 2, and constant a is 2 and b is 4. If we evaluate the left hand side, a times x1 of n plus b times x2 of n, this gives us 6, 8, 14, 16. And if you evaluate right hand side, we need to take 4-point DFT of x1 of n, which is x1 of k, and x2 of n, which is x2 of k. And these are the values we get. Now, if we evaluate a times x1 of k plus b times x2 of k, we get 44 minus 8 plus 8j, minus 4 and minus 8 minus 8j. Now, if I take inverse DFT of this sequence, I should get back my time domain sequence, which is 6, 8, 14, 16. Here, 6, 8, 14, 16. We'll verify it in Scilab now. To verify linearity property of DFT. So you will see clear, close. We shall read all the 4 values. One is x1, and second one is x2. The third one is the constant a, and the fourth one is the constant b. So all these we are going to read it from the console window. Input, enter x1 of n, we copy this, paste it here, Control V, Control V, and Control V. Here, this is input x2 of n sequence, input A and input B. Now we shall verify the left hand side. LHS is equal to A into x1 of n plus B into x2 of n, and will display LHS of the property is, what is it I need to display? LHS. We'll check the LHS first. Before that, we'll save it, linearity property, and go back to console window. Enter the first sequence 1, 2, 3, 4. Enter the second sequence 1, 1, 2, 2, and the sequence is A is 2, B is 4. The sequence is 6, 8, 14, 16. 6, 8, 14, 16. So this is our left hand side. Now we'll see how do we implement right hand side in Scilab. RHS, before getting into RHS, we'll take DFT. Capital X1 is equal to FFT of small letter x1. Capital X2 is equal to FFT of small letter x2. And A, B are the same. So we'll directly look at the RHS now. RHS is nothing but A into x1 of k plus b into x2 of k. Remember, this is actually capital X, and I'll directly, what we did was we took a into x1 of k plus b into x2 of k. Now in this line itself, we'll take IDFT. So IFFT of this entire thing, a into x1 of k plus b into x2 of k. This will be our right hand side. Now we shall display it, RHS of the property is comma RHS. Now we'll see what do we get. Go back to console window, enter x1 of n, enter x2 of n, enter A, enter B. So left hand side and right hand side should be same. So thus we verified linearity property of DFT. Thank you.